Today we talked about number patterns, specifically when it comes to starting with an equation and then filling out a table. And so that's basically what we did in 10.1. So let's start with this problem. G equals n plus 6. We need to fill out this table here. Okay? It gives us some inputs, 1, 2, 3, and 4, okay? And we need to figure out what the outputs are. Now notice that there are some variables here, some letters. Our input is n, and then our output or our answer is g. So what we do is we take these inputs right here and we replace n with what the inputs that you see here, the numbers that you see here, and then just calculate what g is. So if n is 1, I replace n with 1, and then just copy everything else down about the equation, and I get g equals 1 plus 6, which is 7. So, 7 goes in this output, g, for the input of 1. We can do that for all of the inputs. So if our input is 2, we replace n with 2, copy all the other parts of the equation, and we get 8. So 8 is our next output. And our next input is 3, so we replace n with 3, copy everything else down, and we get 9. So we put 9 on our table. And our next input is 4, so we place n with 4, and we get g equals 4 plus 6, and that's 10. Now the outputs looks really nice. You get a 7, 8, 9, 10 in that order, but it doesn't always work out that way. Now this was what we call an additive function because you add. There's an addition sign. Now let's look at a multiplicative one. And by the name, you can probably guess it means multiply. So we have P equals R times 12. So our first input, R, notice that it's on this, our input is labeled as R. That means we replace R with these numbers that are next to R to find our output, which is P. Our first input is 2, so we replace R with 2, and then we multiply by 12, and we just copy everything else down. Now, if you don't know what 12 times 2 is, that's fine. You can just work it out on the side. 2 times 2 is 4. 2 times 1 is 2. So our first output is 24. Now we have another input, and that is 4. So we replace R with 4, copy everything else down. And now we have 4 times 12. So let's work that out on the side. 2 times 4 is 8. 4 times 1 is 4. So 48 is our next input. See, now they don't always go, they're not always offset by 1. Our first output is 24. Our next one is 48. So you always need to calculate it. Our next input is 6. Notice you can pick whatever. They might give you different inputs that are like nice, like 1, 2, 3, 4, or they can give you 2, 4, 6, 8. And what we see, as we'll see in 10.2, when you create your own inputs, you can pretty much pick any number for your input. So our next input is 6, and you just copy all the rest of the equation down. And now I have 6 times 12 is my output, so let's do that on the side. 6 times 2 is 12. 6 times 1 is 6, plus 1 is 7. So my output is 72. My last output for this table, for the function or for the equation P equals R times 12, my last input would be 8. So now P equals 8 times 12. So Let me work that out on the side. 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. And 96 is my output. So I just found some outputs for these inputs. In class, we related these to real-world problems. We had in the book there is a story problem about a flan, how to make flan. The equation was F equals 3E, which means that for one flan or for every egg you get 3 flans. And a number and a letter next to each other means multiply. So F equals 3 times E, and we needed to find out how many flans we would get from 5 eggs. So we replaced E with 5, meaning 5 eggs. We multiplied, and from that we got 15 flans. Now that's from the first problem of 10.1 in the book. That's just an example of what the purpose of this is, of looking at equations and calculating the output of the equation. Our input in this case was 5 eggs. Our output was 15 flans. Okay. So, moving on to some problems that are very similar to what you see on the homework. We're going to do the same thing, but we don't have a nice table. They didn't set up a nice table for us. They didn't even tell us what the inputs were, so I'm going to do that myself. Now, the instructions for these problems in the book is that you need to create 4 inputs and outputs for each equation. So this one is y equals x plus 4, and our input, as it says here, is x. Our output is y, and our equation is y equals x plus 4. Now, I can come up with whatever inputs I want. I'm lazy, so I'm going to pick easy numbers like 0, 1, 2, and 3. Very easy to calculate. And then I just replace my input with these. I replace x with these inputs, and then I get my output. So I replace x. First, I replace x with 0. That's my first input. Then I have y equals 0 plus 4. And that gives me 4. Very simple. I like 0 as an input. Very easy to do. My next input is 1, so I replace x with 1. 1 plus 4 is 5, so that gives me 5. My next input that I've written down is 2, so I replace x with 2, and I get 2 plus 4, and that gives me 6. My next input is 3, so I replace x with 3, and I get 3 plus 4, and that's 7. And that's it. I found a set of inputs and outputs for number 3, for y equals x plus 4. Okay, so I'm going to do the same for this one. I have input S, output A. So S is my input, A is my output. I'm going to use the same inputs. 0, 1, 2, and 3. And you can use whatever you want. You can use 99. You can use 37, whatever you want. But these are really easy to calculate, so that's why I'm using them. So my formula is A equals, oops, that doesn't look like an A, it looks like a 9. A equals 11S. Now, a number and a letter next to each other is the same as multiplication. So I can also write this as 11 times S, but you should recognize that this is multiplication. 11S is 11 times S. Okay, so my first input is 0. So A equals 11 times 0. Well, anything times 0 is 0. So 0 is my first output. Next, my next input is 1, so that's 11 times 1, and that's 11. You can see why I picked the small numbers. My next input is 2. 11 times 2 is, oops, I erased that, 22. And my next input is 3. So 11 times 3, that is 33. Okay, and that's my input-output table for 11 times S. A equals 11 times S. This one here is input U, output V. I'm going to come up with 4 inputs and outputs. So I have V equals 7U, which, once again, a number and a letter next to each other is multiplication. 7 times U. So I'm just going to put some inputs. Once again, you can pick whatever you want for the inputs, but these are really easy to work with, 0 through 3. So I'm going to start with an input of 0. So 7 times 0, and that is 0. And my next input is 1. 7 times 1 is 7. My next input is 2. 7 times 2 is 14. My next input, my last input is 3. 7 times 3 is 21. And that is an input-output table for V equals 7 times U. All right, last one. I have input of M, output of N. Okay. I'm going to use the same inputs because I like them because they're easy. And now I'm just going to erase these first couple. I'm going to erase everything else so I have room. I have N equals M times 10. They could have written this as 10M if they wanted to. It means the same thing. My first input is 0, so I'm going to replace the M with 0, multiply by 10, and I get 0. And my next input is 1, so I'm going to replace the M with 1. 1 times 10 is 10. My next input is 2, so I'm going to replace the input M with 2. 2 times 10 is 20. And my last input is 3, so I'm going to replace the M with 3. 3 times 10 is 30, and that's my input-output table for N equals M times 10.